Let's review some exponent rules. First, what if we have something that looks like this? X to the third power times x to the fifth power. Well, when we are multiplying the bases, like in this situation, all we do is add the exponents. So x to the third times x to the fifth becomes x to the eighth. But what if instead of just x to the third, we had 2x to the third, and instead of x to the fifth, we have 5x to the fifth? It's really not so different, we just want to take it in two pieces. So first, I'm going to look at just the coefficients. This one is 2 and this one is 5. When I multiply those together, I get 10. Then I'm going to look at the x's again. We have x to the third times x to the fifth, and that is still x to the eighth. Try this one on your own. The answer here is 24x to the seventh, because the coefficients multiplied, 4 times 6 gives you 24, and x squared times x to the fifth gives you x to the seventh, because you add those exponents. What if we're dividing instead of multiplying? So here we have a to the fifth times b to the third divided by a to the ninth times b. First, set up your fraction bar. It will help you keep your elements organized. Next, let's just look at the a's first. The exponent in the numerator is 5, and the exponent on a in the denominator is 9. 9 is greater than 5, so there will be a's left in the denominator, so that's where I'm going to write the a. And 9 is 4 more than 5, so that is going to become the exponent on a. So when we are just dealing with the a's, we are left with a to the fourth power in the denominator. Take a moment and see if you can do the same thing with b. Go ahead and pause and then come back. All right, so let's check. The exponent on b is 3 in the numerator and 1 in the denominator. If the letter is there, but we don't have a number indicated in the exponent, that just means the exponent is 1. We just don't usually write it. Okay, 3 is more than 1, so there are only going to be b's left in the numerator. And 3 is 2 more than 1, so the exponent on b is going to be 2. Okay, what if we have something with exponents being raised to exponents? How does that affect our answer? Here, we still just want to follow order of operations. The operations involved in this expression are multiplication and exponents. Exponents come first, so let's deal with that first. The exponent here is 7, and it only applies to the elements inside the parentheses. When we are raising an exponent to an exponent, we multiply. So in this case, we get x to the 14th power times y to the 7th power, because 2 times 7 is 14, and 1 times 7 is 7. Notice that this x times y to the third is just going to tag along for now. It is not interacting with that exponent of 7, so we are going to deal with that next. Okay, so now this looks a lot like the first problem we did, it just has more letters. So I'm going to look at my x's first. I have x to the first power and x to the 14th power. When I multiply those, I get x to the 15th power, because 1 plus 14 is 15. Then I have y to the third power times y to the 7th power. 3 plus 7 is 10, so I'm left with y to the 10th power. Try this one on your own. Go ahead and pause and then come back. So step 1, apply the exponent outside the parentheses to the elements inside the parentheses via multiplication. This tags along, and now our x's interact with each other and our y's interact with each other by adding the exponents since we were multiplying the bases. Last but not least, let's look at this crazy thing. So there's a lot going on, but the only thing that's important here is this 0, because anything raised to the 0 power is just 1.